All right, welcome back. We got day 2 of the notes for 7.1 today with matrices and systems of equations. So we will go ahead and jump right in. First thing we're going to talk to you about today is something called row echelon form, also referred to as REF. If you look under the matrix menu on your calculator, you'll see REF and RREF. We'll talk about the difference of that in a moment. Row echelon form is just a reduced form for matrices. In order to have a matrix in this form, if you have a row that's all zeros, so if you had all zeros across, that row has to be at the bottom of the matrix. That doesn't happen often, but occasionally we'll see that. If you get all zeros to be in row echelon form, you got to throw it to the bottom. Any other row, the leading entry in each row has to be a 1. And if you have 2 consecutive non-zero rows, the leading one in the higher row has to be further left. So if you look right here, you can see row 1, we start with a 1, 1, 5, 8, and then the second row goes 0, 1, and this row is further to the right. And so it has to go in this descending order as you see here. Then the third row went 0, 0, 1. So each row down, the 1 has to be further right than the previous row. When that happens, this is row echelon form. Okay, an extenuation of that is something called reduced row echelon form. First and foremost, if you're going to be in this form, you have to start here. It has to be in row echelon form. And so we can see this example at the bottom. We have a 1, then a 0, 1. Then this 1 here you can see is further to the right than this one, so that's okay. So it's in row echelon form. Second step, the leading entry in each non-zero row is a 1. So again, we don't have any rows that are all zeros, so the leading number in each one of those rows has to be a 1, and that's okay. And the third thing that really separates this, that makes it reduced row echelon form, is the columns. Any column that has a leading 1, the other numbers in that column have to be zeros. So notice here, first column we have 1, the other 2 are zeros. In row 2 we lead with a 1, the other 2 are zeros. This row doesn't matter because it doesn't have a 1. We get right here, this one leads with a 1, the other 2 are zeros. So that's what makes this reduced row echelon form, or shorthand form of that is RREF. All right, so here you see a matrix, and clearly not in row echelon form or reduced row echelon form. And so what we're going to do is we're going to get it there. And I'm going to explain what this means first of all before we get to our next set of numbers. So this negative 3R1, what that means is for this row here, we're going to take this top row, we are going to multiply it by negative 3. Every one of these numbers. So we'll multiply this number by negative 3, 2 by negative 3, negative 1 by negative 3, and 3 by negative 3. Then we're going to add that result to this row. And when we do that calculation, that is going to be our new row 2. So if you look over here, row 1 did not change. Notice we didn't write anything here, so row 1 stayed the same. Okay, our row 2, we're going to take negative 3 times R1. So each one of these numbers, we're going to multiply by negative 3 and add it to the number in row 2. So negative 3 times 1 is negative 3, plus 3 is 0. 2 times negative 3 is negative 6, plus 7 is 1. Negative 1 times negative 3 is 3, plus negative 5 is negative 2. And negative 3 times 3 is negative 9, plus 14 is 5. So that's the calculation we made to get our new row 2. For row 3, we're going to take 2 times row 1 and add that to row 3. So 2 times 1 is 2, plus negative 2 is 0. 2 times 2 is 4. 4 minus 1 is 3. 2 times negative 1 is 2, or excuse me, 2 times negative 1 is negative 2, minus 3 is negative 5, and 2 times 3 is 6, plus 8, giving us 14. Now, why did we choose that particular set of numbers to multiply and add to? The biggest reason why we did that, see we have a leading 1 in the first row, and I want to make these zeros. So by multiplying this by negative 3 and adding it to here, I made that a 0. By multiplying row 1 by 2 and adding it to this one, I made this a 0. Now, added bonus, I didn't count on this, but it happened to work for this one. Notice row 2 now has a leading 1. So we have a leading 1 here, a leading 1 here that is to the right of that one. So these first 2 rows now are in row echelon form. Now we can tackle this row. So I want this to be a 0. I'm going to, and what you can see down here already, kind of foreshadow, but I'm going to multiply this new row now by negative 3 and add it to this one. So when I jump from here down to here, notice row 1 didn't change. Row 2, we left it as is from this step here. And our new row 3, I multiplied this row by negative 3 and added it here. So negative 3 times 1 is negative 3, plus 3 is 0. Negative 3 times negative 2 is 6. 6 minus 5 is 1. Negative 3 times 5 is negative 15. Plus 14 is negative 1. And so now you can see this matrix is now in row echelon form because we have a leading 1 in each row, and each one is further right than the row above. It is not in reduced row echelon form, however. If it was going to be in reduced row echelon form, this number would have to be a 0, and these two numbers would have to be 0. But that's not what they're asking us to do. They just want us to get it to row echelon form. And so when you see this little shorthand here, this is telling you what we multiplied a row by and what we added to it to get to next step. I will do one more example of that, and then we'll wrap up our notes for today. All right, so again, you see that we have a matrix that is not in row echelon form. The nice thing here, I've got a 0, which is fine. I'm going to leave that row for right now. So you'll see when we get over to our steps here, actually going to leave this row and leave this row. What we're going to do is we're actually going to switch them. And the reason I'm going to do that, see, it's not a positive 1 yet, it's a negative 1, but we're going to put it up here because we are going to make this a 1 eventually. And so now I have negative 1 and 0, negative 1. We'll handle that in a minute. And so I just changed the order of these rows, which we're allowed to do. Now the next thing I'm going to do, I am going to take this one right here, and I'm going to multiply that by 4. And the reason I'm going to do that is if I multiply this by 4 and add it here, I'm going to get a 0. And that's what I'm looking at. So notice it says 4R2 plus R3. That's referring back to the previous step. So 4 times this row plus the bottom row. So 4 times negative 1 is negative 4 plus 4 is 0. 4 times 12 minus 5 is 7. 4 times negative 7 is negative 28, plus 1 is negative 27, and 4 times 6 is positive 24, plus 3, positive 27. At this point, we are really, really close to getting to where we need to be. So we're going to jump down here real quick. And so from step 2 to step 3, how did I get to this point? Well, I want this to be a 0 as well. So I'm going to multiply this row right here. You can see I took 7 times row 2. This is always referring back to the previous matrix. So 7 times this row added to row 3. So negative 1 times 7 is negative 7 plus 7 gives me this 0. 7 times negative 5 is negative 35 minus 27 is negative 62. 7 times positive 5 is 35. 35 plus 27 for positive 62. At this point, we are almost to where we need to be, and we got one last step here. I want this to be a positive 1 and this to be a positive 1, so our final step is we will just multiply both of those rows by negative 1. So if I take this top row times negative 1, that is going to change all of these numbers here. This will be 1. This will be negative 3, positive 7, and negative 6. If I do the same thing to the middle row, if I multiply by negative 1, the 0 stays the same. This will be positive 1, positive 5, and negative 5. Now the last row, if I take this, I want this to be a 1, so I can just take a fraction. Remember, we can multiply by anything as long as it's non-zero. So I just multiplied by negative 1 over 62. That's going to make this positive 1, make this negative 1, and we're all set. So again, starting from a matrix that's not in row echelon form, following these sets of steps will get us down to a matrix that is in row echelon form. Again, you see each row has a leading 1, and the middle row, this 1 is further to the right than the top row, and in the bottom row, this 1 is further to the right than the middle row. And so that is what we're after when we're getting into row echelon form. All right, that continues, or completes actually day 2 of our notes, and we'll see you in a couple days for day 3 of the notes for 7-1. Thanks.